Okay, it's 1 p.m., so let's go ahead and get started, everybody. All right, good afternoon, everyone. How's everybody doing today?
All right.
Cramming for the homework and midterm on Saturday.
Oh, a midterm on Saturday. Oh man, that's a nice parting gift right before Thanksgiving.
Yep, don't know why she does that, but it is what it is.
Well, at least you won't have to study over Thanksgiving. I guess that's a good thing. But yeah, it's tiring. You know, this is we've reached this part of the semester. You know, we've been going at it for at this point 12 weeks in a row now without any breaks. So it's brutal. So I actually came from all of my college experience was in quarter system schools actually. So all the quarters are only 10 weeks. And so, you know, there's pros and cons to that, but at least, you know, after the 10 weeks, then you have a break. So to have the semester, while it's nice to be able to go slower in some respects, it's also extremely long too. So you go a really long time without having any breaks. So it's tough. And I know it's this part of the semester must be tough for you guys too. Okay. So first thing I want to talk about today is the midterm. So I did finish grading those last Friday. So I know it was kind of 2 days later than I was than I kind of promised initially. But yeah, there was kind of a lot of stuff I had to do at the end of last week. But I did get done by Friday, and the average was really high. And so the average was 43.5 out of 50. Right? And so considering this and considering the average on the first midterm, which I think was you know, close to this or you know, maybe a little bit lower, I don't anticipate there being any kind of curve or any kind of grade adjustment at the end. So since the averages have been pretty high and your guys' homeworks have been kind of up there as well, you know, I think the grades are just going to stay, you know, stay as they are. I mean, granted, you know, there's still a large percentage that has to be put in from the final project and then from participation too. But you know, if things kind of stay steady as the way they are, you know, you know, I wouldn't expect any kind of adding any points, which I've done in the past. But for the virtual classes, because you know everything is you have, you know, I give you guys more time on the exams and everything like that. You know, the averages are just naturally a lot higher. So. And so, you know, you can basically just look at your point total right now and kind of forward that to your final grade, assuming, you know, things with the final project and everything stay about the same. Okay. Okay. And so that's the midterm. And then, so the plan for today is to continue on with our lecture notes on safety and risk. So I think we did about half of it last week, and so today we're going to cover the other half, which has more to do with, you know, how do we communicate risk? How do we form public policy? And just different kind of general techniques that you can do to help plan for any kind of risky situations or any kind of safety issues. Okay. But before we get started, are there any questions I can answer?
You're dropping the lowest homework score, right?
Correct. Yeah. So the lowest homework score will be dropped, and Canvas should do that automatically. I think it was already doing that at the beginning of the semester too. So I think if you look at your grade right now, I think it already drops your lowest homework. No, unfortunately, I can't drop the lowest midterm. Both midterms are going to stay in there. Yeah. Okay. So there's no more questions. Let's go ahead and get started. Okay. So last time, I think we ended with that case study about. You know, the Teton Dam, right? So we read about this this dam that was in Idaho that basically, you know, failed, just mostly due because the engineers and the management there didn't take enough of the risks into view. Okay, and in particular, you know, we talked about kind of the different perspectives on which risk that people can view risk. So we talked about, you know, the public's view to risk and what their consequences are, and we talked about, you know, what are the government regulators' responsibilities in terms of engineering risk, right? And so today, what we're going to start with is, you know, we're going to start about how do we as engineers take a role in communicating risk to the public, and how does this help inform public policy. Okay. Because, you know, our job as engineers is not only to just determine the risks, but also, you know, to effectively communicate this to the public and to, you know, help the government form, you know, responsible laws regarding this. Okay. Okay. So to start, so we've already seen that there's different groups of people that have different perspectives regarding risk. Okay. Okay. And so the main three that we talked about was one, the engineers, which is us. Second one was the public, or you can think of the public as like your consumers or the people that are going to use your products and services. And three are the government regulators. Okay? So these are the people in government that write the laws that that you have to comply to. Okay. Okay. And so all of these, you know, they all come at risk with a different perspective. Okay. And so, you know, even though we're the ones that are often creating the technology and developing the tools, you know, we have to acknowledge that, you know, the opinions and the viewpoints for, you know, both the public and the government regulators, these are, you know, extremely important when designing and when designing your technology, but also creating public policy or creating laws that that have to do with your engineering projects. Okay. And so, in other words, you know, I write it like this just on purpose because even though you know, oftentimes we see ourselves as kind of the most important party because you know we are the ones that are actually developing the technology. We're only just one out of many. Okay. Okay. And so the most important, the most successful engineering products and the most successful engineering technologies are the ones that kind of successfully navigate, you know, these three different parties here, and kind of satisfy all of their needs. Okay. Okay. And so you know, in interacting with these different groups, you want to ask, or the fair question to ask is, what is our responsibility regarding risk? Okay. Yes. Or I should say, what is our responsibility in informing, you know, the public and informing the government regulators about risk? Okay. And so there's kind of two approaches that you can take this kind of generally. I mean, of course, there's lots of different strategies according to this that regard this, but you know, there's kind of two broad approaches. Okay? And so one approach is to simply, you know, just put your technology out there and let the public and the government regulators form their own opinion and then adjust based on their feedback. Okay. Especially now with the social media age, it's very easy to gather people's opinions on certain things. You just have to kind of have to search for it on Twitter or Reddit or something like that. Okay. Another approach is to so this is kind of like a laissez-faire kind of approach. Like you kind of just, you know, put it out there and you just let the chips fall where they may, and then wherever they fall, you just kind of you know, adjust from there. Okay. And so another approach is to, you know, actively participate in the conversation and, you know, and with the dissemination of information. Okay. And this approach is, this approach kind of recognizes the fact that, among all the different groups here, between the engineers, the publics, and the regulators, we can bring something to the table that they don't have, which is, the technical expertise, right? And so, this piece right here is something that's really important to that conversation, because, you don't want the conversation about risk in your technology to be, based on just initial impressions or misconceptions, right? And so, you guys have the technical expertise, you have the data, you have the, the knowledge to basically bring to the table something that the other groups can't bring, right? And this is incredibly important when you're talking about public policy, right? And so, of course, you as engineers, you want, people that use this technology, and you want people that, you want the laws to basically protect people as much as possible, right? And in writing these laws that regulate this technology, you have to be able to participate in these conversations. Otherwise you're gonna end up with laws that either don't make sense or they don't, protect the public at all. Okay. But you also have to keep in mind that, you also want these laws to be not as strict as not be overly restrictive, because you also still want to encourage innovation in your field as well. Okay. Right. So generally, the approach that people take nowadays is actually the second one. Okay. And so, because in the second one, because we public policy and public opinion, they inform so much about our world nowadays. It really helps more to just take an active part in that conversation, and to kind of, make sure it doesn't go in kind of the wrong directions. All right, any questions on this? Okay. Okay. And so, if you are going to take an active part in the conversations, this usually takes place at the level of like the managers and, the higher ups in your company, right? When you do take parts in these conversations, you have to be really careful about how you talk about risk. Okay. Okay. Because we've already talked about before that, your concept of risk, is very different than, how other people follow it, right? Because we've already kind of talked about before that, when people say risk, they kind of immediately assume that something bad is going to happen. Okay? And so here's some guidelines that are from the textbook that can help you in, to explain the risk of using these engineering technologies, right? And so kind of a good exercise that you can do is, if you want to explain, something that you're doing in your class or something that you're working on either in your senior design, you can use these guidelines to talk about risk to like your family members or friends that are outside of engineering. Okay. Okay. All right. So first guideline. Right? So the first guideline is just to be aware that your understanding and perception of risk can be very different from others outside engineering. Okay. Okay. So I see there's a question in the chat. Let me see that. Yeah. So Tom brings up a great point in the chat. So if there's any risk or any doubt in their projects failing, then you have to be sure that the risks are real and potentially do a recall. Yeah. So that's a really great point right there. Mm-hmm. Yeah. Because remember, the word risk is just by itself is kind of a risky word to use, right? Because because usually when we say risk as an engineer, what we mean is the probability of harm. Okay. But, you know, when other people hear risk, you know, what they might hear is that, you know, something bad is going to happen, right? And so I remember, you know, when I first got into college, you know, they gave everyone a water bottle as a gift. But, you know, inside the water bottle, there's this warning, and it's kind of on a big piece of paper that said, you know, this water bottle was manufactured with materials known to cause cancer. So you carry the risk of using cancer. So at the time, you know, I didn't know anything about how water bottles were manufactured. So, you know, at the time, you know, everyone got this like, wow, is this water bottle going to give us cancer? What a nice welcome to college gift that the school was giving us right now. So, you know, you have to be careful. So, you know, it's important to be, you know, upfront and clear about, you know, how things can harm people, but you have to be kind of explicit about, you know, what are the real possibilities, okay? Because otherwise you might give people a really wrong impression. Yeah, every product in California causes cancer. I think there's now I understand there's a law that kind of requires manufacturers to say that, but you know, you have to be careful when you talk about risk. Okay. Okay, number two. Okay. So number two, you know, is just the fact that even though, you know, we know that we bring the most technological or the most technical knowledge to the conversation, you also have to know that not everyone is going to trust you right away. Okay. And I think even nowadays it's even more complicated. But you know, just within the realm of engineering, you know, there have been times where experts have been wrong in the past, right? Even in your own field, right? So it's important to kind of acknowledge that, you know, even though you are bringing the most technical knowledge to the conversation, you know, there are still oftentimes limitations to your knowledge. Okay. So, you know, I think this is important to kind of recognize and kind of just be kind of really honest with yourself too, because even though, you know, you might be the only engineer in the room and you might be the only one that understands how the engine works, right? But at the same time, you know, you have to acknowledge and kind of be honest that, you know, there still might be some limits to your knowledge, right? So, you know, you might not know how the engine is going to perform in every single situation, right? And so you're going to have to be honest and say, you know, these are the tests that we ran and this is the data that we have. But, you know, if you kind of try to extrapolate kind of more beyond that, you kind of put your own credibility at risk. Okay? And also just, you know, especially nowadays, just be prepared for, you know, even when you do present evidence, you do present data, you know, a lot of times people are going to rely on their own viewpoints and their own kind of anchoring. That's what we talked about before, instead of listening to your own. So, you know, that's just something to be aware of. So it's, you know, communication, I think, is getting more and more difficult by the day. So, you know, I think the important thing to always remember is that, you know, you bring a certain perspective to the conversation and other people bring a perspective, you know, and, you know, there's going to be some disagreements that happen just because everyone has their own viewpoints. But, you know, the important thing is to always kind of be respectful and to try to compromise and try to find kind of the best way forward for everyone. Okay. Okay. And so the third guideline specifically has to do with government regulators. And so when you're dealing with, you know, people who write the laws, you have to understand that they have a special obligation to protect the public. Okay. And so because of this, you know, the government regulators are always going to be risk adverse, right? And so you kind of have to keep that in mind because it's, you know, if there's any kind of possibility that people can be really harmed, you know, government regulators are going to step away from that. Okay. Okay, and so if you kind of follow these guidelines, these will help you. You know, and I'll say that, you know, communicating these things is never going to be easy. It's always going to be something that's difficult. And you know, a lot of times you'll leave a conversation with someone and you'll feel like it went terribly. But you know, it's a hard thing. But you know, just you know, if you follow these guidelines, at least you know you can at least help you. Okay. And so one example of all this kind of working together is in the development of building codes. Okay. And so if you're not familiar with building codes are basically the rules and basically the factors of safety in the construction steps that are required in every building to make them basically safe, right? And so in California, you know, one big thing here is earthquakes. So, you know, building codes are there to basically make sure that your buildings won't fall apart in an earthquake, okay? And so the thing with building codes, these are actually, you know, laws, or you know, true laws that are in, you know, the in public policy, right? And so these building codes, they can't be changed without, you know, either public hearings or any kind of legislative action. Okay. And so to write these building codes, governments will often appoint committees of experts to propose new building codes or to make, you know, any kind of revisions. Okay. So engineers, you know, regularly take part in these building codes, in these committees. Okay? Okay. So, you know, engineers are going to be there, you know, government regulators are going to be there. Everyone kind of comes to the table, you know, to kind of bring something, you know, to that conversation. Okay. Yes. Yeah. Yeah. So Tom brings up a great point too. So so for the homework 6, you know, the City Corp building, you know, that was one case where the New York City building code didn't, you know, they weren't able to withstand that crosswind too. Yeah. Mm-hmm. Yeah, that's a great example. And so, you know, this is kind of one thing where, like, if you take part in making these building codes, you're going to be at a table with, you know, government regulators are going to be there, representatives from the public are going to be there, contractors are going to be there, you know, material people who procure the materials, budgeting, finance, you know, it's going to be it's going to be a table with a lot of different people. So, you know, when you're communicating these issues of, like, you know, building safety, you know, you have to kind of keep in mind, you know, of all the different perspectives and all the different people that are going to be there. Okay. And these you know, these have a big impact on how buildings are made, because it's going to change, you know, what type of materials are used, what type of construction method is used, or, you know, what's the timeline and all that stuff. So it's important, and you want to make sure that that you're you know, you're open and you communicate, you know, the risks as publicly as you can, so that, you know, everyone can kind of do their job well and to make sure the buildings are safe. Okay. Okay. Any questions on this? Okay. And so that's some guidelines on how to, you know, best communicate issues of risk and safety in your engineering practice. Okay. And so the next thing I want to talk about is difficulties in actually determining the causes of harm. Okay. 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 And so, you know, in order to safely design your engineering products and technology, you know, a big part of this is actually able to predict or estimate what the dangers are. Okay. Because if you can't predict, you know, what some of the dangers are, then you're not going to be able to know what you're going to design against. Okay. And so the better your predictions, the better, you know, you can safeguard against them, right? And so, because if you know for sure that, if you design like an engine in a certain way and this part is going to fail, then you can design, the engine to not have to rely on that part, or to avoid that. Okay? And so the problem with this is that, forming predictions is not an easy task. And actually, sometimes it's a really difficult task. Right? And so just kind of speaking just from my own experience. So I've a lot of my own kind of research and a lot of my previous work is in simulations, right? And so the point of like a finite element simulation, like you're using ANSYS, is to predict if something bad's going to happen before you actually build, right? And so you can do a finite element simulation of like a building and to see if it will break down in an earthquake before you build the building and it breaks down, right? And so the problem with this is that it's really hard, even with simulation technology nowadays, as powerful as it is, it's really hard to get a good handle of, how things are going to react in a certain way. Because a lot of times you just don't have all the information. Right? Especially when you're working with any kind of new technology or a new application or a new setting, it's really difficult to determine, what are all the things that can go wrong. Okay? And so even though it's difficult to predict all these things, there's some tools that we can use that can kind of help. Okay. And so one tool that we'll go over today is called a fault tree. And so this is kind of a general method, so it's not specific to just engineering. And so you can actually apply this to a lot of other things in your life. Okay? But the idea with the fault tree is that you basically start, or you make your diagram and you start with some kind of undesirable event. Okay? Okay. And so the example that I'm going to carry out for this is going to be, let's say that your car won't start. Okay? Generally seen as an undesirable thing, because otherwise you wouldn't be able to drive and get to not that people are driving much nowadays, but it's still not a desirable thing. Okay. And so what you're going to do from here is that after you come up with your undesirable event, from here you should come up with all the possible reasons as to why this may have occurred. Okay. And so, some examples are if your car won't start, maybe the battery's dead, or maybe the fuel system is defective, or maybe you're just out of gas. Okay, it could be that you could have someone vandalize your car, they stole it, right? So there's lots of different reasons why a car won't start. But it's important to kind of list every single one that could happen. Okay, okay. And then from here, once you've determined all of these direct causes, we can then expand the tree to detail some of the events that lead up to these failures. Okay. And so as you kind of keep expanding your tree, so you say, my car won't start and my battery's dead. And one possible reason for this was I left the lights on last night. And then as you kind of expand this, you kind of come up with all these situations where, the idea with the fault tree is to kind of enumerate and kind of, list out every possible thing that can go wrong, just so that you can kind of help prepare for them. Okay? And so this is really useful for engineering analysis because it helps you determine what's called all the failure modes. Okay. And so failure modes are just basically just different ways that a structure can fail. Okay. And so just as an example, when you talk failure modes for like a structural beam, right? And so the different failure modes could be like it rips apart in tension, it either crumbles in compression, it breaks in bending, or it loses integrity in corrosion. So lots of different things. Okay? But on the next page, I'm going to give you an example of a fault tree for this example here of a car not starting, just to kind of give you an idea of what you can do. Okay. Because the fault tree would be something that'd be good to include in your final projects too. So I think in the project I asked you guys to include a few figures. One figure that you can include is a fault tree, right? And so you can start with kind of the bad thing that happened in your case study, and then expand this into all the different possible causes for this. And then you can use that to kind of help inform maybe something that the engineers could have done better to prevent this from happening. Okay. So before I do that, are there any questions on this? Okay. All right, so let's do an example of a fault tree. So let's do the example where your car won't start. Okay. And so remember, with the fault tree, you start with some kind of undesirable event at the top. So this is our undesirable event. Okay. And then from here, what we're going to list out is all the different causes for this, for why your car won't start. And so one possible cause could be just that the battery is dead. Okay. All right, so another cause for this could be that the fuel system is defective. Okay. And so another cause for this is engine problems. Okay. And so the full chart of this can actually be seen in the lecture notes. So I'm just going to write just kind of an abbreviated version here, but you can look at kind of all the things that they've listed out there, and it's quite a lot actually. So there's a lot of ways that your car can break down. All right, and so the last one we'll go over is just any kind of mischievous or vandalism. Okay. Mischievous acts or vandalism. Okay. And so, this is kind of the second step of the fault tree. So the second step of the fault tree is to kind of list out what I call these to be like the primary causes. Okay? And so basically what these are is that, if one of these systems or one of these causes are satisfied, then that will directly cause your car to not start, which is your ultimate kind of non-desirable effect. Okay. And so from here, what you can do is you can start to list out, reasons why, these direct causes may have occurred. Okay? And so let's start with, your battery's dead. And so one reason for this is that you just leave the lights on all night. Okay. And so another reason could be that your battery has rusted or corroded. Okay. Okay. Another reason could be that there's just simply like a loose connection. Okay. Okay. And the list kind of goes on from here. So there's lots of different ways for that. Okay? And so let's do vandalism now. Okay. So I'm not going to do all of them, just because I don't have enough space for all of them. But hopefully by these two you kind of get the idea. Okay. And so one reason why under vandalism that something your car won't start is just someone just simply stole a part of your engine. Okay. Okay. And so another case of vandalism that would cause your car not to start was that somebody just took all the gas in your car. So they siphoned your gas. And so a third reason, maybe due to vandalism, that someone just disrupted the wiring. Okay. All right. And so you can kind of continue this as many as as much as you can for as many kinds of events that you can think of too. Okay. And so once you've written the fault tree, you can kind of look at all these different causes or all these different events, and you can think about what are some things that you can do to prevent these from happening. Okay? Yeah, siphoning gas, it's a tricky one, but it's possible. I've seen people done that. Okay, and so you can look at things like maybe let's look at let's look at the battery, because I think that's kind of the most straightforward, right? And so one cause that for your battery being dead is that you left your lights on, right? And so one thing that you can do to prevent this is to just every time that you leave your car, just kind of make a double check just to make sure that your lights are off. Okay. And so, for the case where your battery is just simply rusted or corroded, one thing that you can do is you can kind of, make sure to check your battery every now and then, like maybe, depending on the age of your car, just make sure your battery's in good shape, right? And if your battery starts to, exhibit rust or corrosion, then you can actually take it in, get a new battery, and, have that be there too, okay? And so, to prevent things from to prevent people from stealing things from your car, you can, make sure your car is better secured. Maybe put a lock on your gas tank or something like that, right? And so, listing out all these possible reasons, even though, a lot of these may seem pretty obvious, right? But, even the most obvious things can kind of fly under the radar, if you don't kind of write them out explicitly, right? And so the fault tree is, the point of it is not to kind of discover new things that might happen. And so a lot of times you write a fault tree and you're like, oh, I didn't think of that before. Sometimes it might be like that, but a lot of times writing the fault tree is to kind of just write out everything that could go wrong or all the events that could lead to failure, and then think about what are some things that I can do to prevent some of these from happening. So it's more of an organization trick more than kind of a discovery kind of thing. And of course, writing a fault tree, it helps to do this in a group as well, because sometimes people bring a certain perspective, or they can say, some things can happen that you might not have thought of as well. Right? And so a fault tree is simply just a tool to kind of help you to kind of list out all these things, so that you can better prepare for them and prevent some bad things from occurring. Okay. All right. Any questions on the fault tree? Okay. And so a fault tree is kind of one tool that you can use to help you plan for risky situations, okay? But this is kind of, it's kind of a tool for kind of risk prevention, right? So if you think about it, you write a fault tree to kind of think about everything that could go wrong and to kind of prevent those as much as possible. Right? Oh yeah. I'm sure probably people, you guys have probably written a fault tree to some degree, but that's kind of just the name for it. Okay. And so a fault tree is kind of good for thinking about how to prevent bad things from occurring. Okay. But another tool that could be useful is to say if you work under the assumption that something bad were to occur, right? It's important to also predict the consequences. Okay. Because you kind of have to recognize that even though you kind of do your best to kind of prevent bad things from happening, sometimes they're still just going to happen anyway, right? Especially when you're dealing with consumers that may not know the best ways on how to use your product. Okay? And so being able to predict the consequences is also a great tool to help you manage these risks as well, right? Because if you know that there's, you know, a certain catastrophic consequence of something happening, then that can influence your design to say, we might not be able to prevent, this bad thing from occurring, but let's at least prevent this really bad consequence from occurring, right? And so one area where this kind of comes to mind is like identity theft, right? So it's with so many, with so much of your information out there, it's so hard to kind of always protect your identity. And so, what companies can do now is that, of course, they're going to try their best to prevent, your information from being stolen. But in the event that does occur, they can try to at least prevent some of the worst consequences from occurring, where like people take out a huge loan in your name, or charging a bunch of money on your credit card, right? So there's a lot, if you kind of, look at your credit card, there's a lot of mechanisms in place to kind of prevent these kind of bad things from occurring, bad consequences in the event that something bad does occur. Okay? And so this is especially important in engineering because, engineering systems are often insanely complex. So they're very complex networks of different technologies working together. Okay. And so, like, if you think of like an engine, there's lots of different components of your engine, and they're all working together. Right? And so, if you have a failure in one of these subsystems or just one component of your engine, it's going to cause impacts on everything else, right? And so, quantifying these and enumerating them out is something that's really important. Okay. And so, we have another tool for this that can help with this, and that's called an event tree. And so an event tree, the way an event tree works is that it tries to predict every possible bad thing that can happen if a certain thing were to occur. Okay. And so on the next page, I'm going to give you an example of an event tree, and then after that, we're going to do an activity for you guys to write your own event trees. Okay. But before I do that, are there just any questions on this? Okay. Okay, so let's do an event tree for let's say a nuclear plant. Okay. And so let's consider the situation where a pipe breaks somewhere in the nuclear plant. Okay. And so, something bad has happened. So, we could have written a fault tree to kind of, try to prevent this from happening. But now that the pipe is broken, now let's try to predict all the consequences. Okay. Okay. All right. So let's start with kind of our initial event here. With our pipe breaking. Okay. And so the way that the event tree works is that it kind of looks like a tournament bracket. Okay. Okay. And so let's start with the pipe breaking. So basically, on every leg of this event tree, we're going to assign a probability. And so this P1, this represents kind of the probability that the pipe is going to break. Okay. And so basically what this states is that we have a probability of P1. So maybe P1 is something small. Hopefully it's something like in the order of like 1%, right? And so on the 1% chance that we, that our pipe breaks, then we kind of advance on this part of the tree, okay? And so we can say that we start right here, and then if the probability is satisfied, so, if the event occurs, then we kind of advance to this next part of the tree right here, okay? Okay. And so in this next part of the tree, let's consider the situation, or the first immediate consequence could be on the electric power. And so the electric power to the plant. And so if a pipe breaks, what we're saying is that the first consequence that's going to occur is that the electrical might fail in the plant. Okay. And so there's two cases here. So the electric power can either be available or it can fail. Okay. So let's do the fail case first. Right. And so what we do at this point is that, if these are our two consequences, or these are the two things that can happen, right? We assign a probability to them of them occurring. Okay? And so, if we kind of reach the point where the pipe breaks, then we can also say that there's a probability of P2 that the electricity is going to fail. Okay? Right. And so that's that's kind of the probability of something bad that's going to happen. Okay? And then if there's a probability of P2 of the electric power failing, then the probability of the electric power still being available is 1 minus P2. Okay? Right? And so in this case, if the electric power fails, we can say that this is catastrophic failure. So the nuclear plant's going to melt down, which is really, really bad. Right? And so in this case, if the electric power fails, we can say that this is a very large release. A very large release of toxic chemicals. Okay. Right. And then from this very large release, we can compute the probability of this occurring, right? And so the probability of this occurring is going to be P1 times P2, okay? Right. And so what we're basically saying is that if we have both the pipe breaks and the electric power fails, that's going to lead to catastrophic failure. But the probability of that occurring is that first the pipe has to break, and so that has a probability of P1. Then the electric power has to fail, and then that has a probability of P2. And so the probability of both of those occurring at the same time is P1 times P2. Okay. Does that kind of make sense to everyone and how I did the probabilities for that?
Why does it say 1 minus P2?
So the 1 minus P2, that's the probability of the other event occurring. And so, if the pipe breaks, one or two things can happen. So either the electricity is going to fail, or it's not. And so if we assign the probability of P2 to be, the probability that electricity is going to fail, then if the electricity doesn't fail, then it is still available. So 1 minus P2 is like the probability that the electric powers will still be available.
Okay.
Yeah, so it's either one or the other. So it's kind of like if you roll a dice, right? If you roll a dice, then there's a 1 in 6 chance that the number 3 is going to occur, right? But if a 3 doesn't occur, then you're going to roll either a 1, a 2, a 4, 5, or 6. And so the probability of rolling something that's not a 3 is 1 minus 1/6, which is 5/6. Okay, and so from here you can kind of continue the tree. Okay? And so let's say that if the electricity is available, we have another bad consequence that can occur, which is fission product removal. Okay, and because even if the electricity is still available, that pipe break can still cause this bad event for fission product removal to fail. Okay. Right. And so from here, the path can split again. Okay. And so again, we'll have the bottom path be failure. Okay. And the top path here will be available. Okay. And so, we can assign probabilities to this too. So we'll call this P3. And this will be 1 minus P3, okay? And then again, if we have this case where this fission product removal that fails, then we have another bad event that's going to occur. Okay? And so let's say that this here, if this occurs, this is only going to be a medium release. Okay? And so the probability of this occurring would be P1 times 1 minus P2 times P3, okay? And so basically, the idea with the event tree is to basically say that, if you have something bad that occurs, what are all the consequences that can occur from this, and what are the probabilities of all those things occurring, okay? All right, does this kind of make sense to everybody? Any questions on this? The figures look a lot nicer in the lecture notes because it's here I have kind of a limited space, but hopefully you guys can kind of see just the idea of these guys. Okay.
Wait, is that P1 times 11?
It's P1 times 1 minus P2. So those are parentheses here.
Thank you.
Mm-hmm. Okay. And so, this can be, another really useful tool to help you mitigate risk, or at least to mitigate some of the consequences in case, bad things occur. Okay. But, one thing I want you guys to keep in mind is that, these probabilities right here, these P1, P2, and P3, sometimes these are really hard to really predict ahead of time, right? Because sometimes you don't know. Because sometimes you don't know, what you hope is that, the probability of a pipe failing is really low. But sometimes you don't really know what that is, right? And then to predict kind of all the probabilities downstream of this can be really difficult as well, okay? But it's not this exercise it's not really something to really quantify things exactly. Again, it's just another tool to kind of help you be aware of all the possible things that can happen. Right. Okay. And so with that, I want to do an activity. And so in this activity, I want you guys to draw an event tree for something, for certain kinds of undesirable situations, okay? And so these aren't going to be engineering related because, that would require a lot of, calculations. But I want you guys to take a look at some things like, say, you lost your wallet, or let's say that you got sick, you got a cold, or let's say that you burned your dinner, right? What I want you to do is to start your event tree with something, that was undesirable like that, and then try to predict all the possible consequences that can occur. Okay. Right. So I see that I've lost a connection here. Okay. And so just like before, I'm going to split you guys up into groups. Okay. And so I'm going to split you guys up into let's do 8 different groups, and then I'm going to give you each group kind of an event for you to draw an event tree for. Okay. So does that kind of make sense to everyone? So so you're going to come up with a event tree, within your own groups, and then we're going to come back and share it again later. Okay. Okay. So I'm going to go ahead and split you guys up just like I've done before. Okay. Okay. And then I'm going to visit each of your rooms and give you the event that you're going to do. Okay.
Hello.
Hey, group 1. How are you guys doing?
Whoa, good.
Good. Okay.
Hi,
So
man.
so for you guys, I want you guys to make an event tree for losing your wallet. Okay. And so in person, the way this works is that someone usually writes it down, and you all can work on it. And so you can either do this with either like a Google Docs or something like that, or someone can just write it down and kind of share it like this. But I want you guys to think about, if you lost your wallet, what are all the bad things that can happen after that, and what are the relative probabilities of that occurring? Okay. That
Okay.
make sense?
Gotcha.
Yeah.
Okay.
Hi.
Muted. All right, group 2, how are you guys doing?
Good.
Okay, so for you guys, I want you guys to write an event tree for catching a cold. And so if you caught a cold, I want you guys to predict, what are all the possible bad things that can occur in your life if you caught a cold, especially, maybe at this time of the semester, what are some of the bad things, okay? So the way this worked before was that usually, someone wrote it down in person, and you guys kept track of that. But for you guys, you can use like Google Sheets or something like that to kind of help keep track of that. Okay, all right, make sense?
Yep, got it.
Okay. All right, group 3, how are you guys doing?
Good.
Okay, so for group 3, what I want you guys to do is I want you to make an event tree for, say that you burned your dinner while you were cooking, okay? And so if you burned your dinner, what are all kind of the bad things that can happen from that going forward, okay? And, and for each of those, I want you to assign a probability, just like we kind of did in the last example, okay? All right, make sense?
Yeah, makes sense.
Okay. All right, group 4, how are you guys doing?
Pretty
Doing
good.
good.
All right, group 4. So group 4, I want you guys to make an event tree for if your apartment or your home is messy, okay? And so let's say that, you haven't been cleaning your apartment and it's just a mess. So, what are all the bad things that can occur, if your apartment or your home is a mess, okay? Does that make sense?
Yeah.
Uh-huh.
Okay. All right, group 5, how are you guys doing?
Oh, we're alive.
It's good. Okay, so group 5, what I want you guys to do is I want you to write an event tree for if you were late to a job interview, okay? And so if you're late to a job interview, what are all the bad things that can occur, or what are all the bad consequences that can occur from being late to a job interview, okay? All right, make sense?
Yes.
Okay, all right, so I'll let you guys get to it. All right, group 6, how are you guys doing?
Good.
Good. Okay, so for group 6, I want you guys to write an event tree for spraining your wrist, okay? So if you sprain your wrist, what are all the possible consequences that can occur after doing that, okay? All right, make sense?
Yeah.
Yeah.
All right, I'll let you guys get to it. All right, group 8, or group 7, how are you guys doing? So there's only 2 of you, so I think probably I'll come back to you guys after after I kind of give the instructions to everyone. Just to kind of help you guys out. But for you guys, I want you guys to write an event tree for if your phone ran out of battery. Okay, so if your phone runs out of battery, what are all the bad consequences that can occur from that? Okay, right, make sense?
Yep.
Okay. All right, group 8, how are you guys doing? You guys are the last group.
Oh, we're good.
Okay.
Yeah.
So, all right, so for you guys, what I want you guys to do is I want you to write an event tree for if you fell asleep during lecture, okay? And so what are all the bad things that can happen if you fall asleep during the lecture?
Okay.
Make sense?
Yeah.
Okay, all right, I'll let you guys get to it.
All right, thank you, sir.
Yep. right, welcome back, everybody. So wait a little bit more for everyone to come back. All right. I think everybody's coming back in, right? All right, so welcome back, everybody. So hopefully everyone enjoyed that activity. So we don't have that much time left, and I do want to cover one more small thing. But before I do that, I just want to let people share just very quickly. What was one of the most dire consequences, or what was one of the worst things that could happen? Starting from that event that I gave you. So does anyone want to share what was kind of one of the worst things?
Yeah, for losing your wallet.
Yep.
I guess getting your identity stolen would be the worst case.
Yeah, definitely. I think that would be one of the worst case scenarios for that to happen. Yeah. So hopefully, so unfortunately, it's hard for me to kind of go and see how everyone's doing. And actually, I spent this time kind of debugging my iPad. But hopefully, you guys can see that this event tree is something that you can use for your projects, or even just, in general, to help you quantify and kind of, plan out what are some of the consequences and risks that can occur. Okay. And so there's one more thing, one more small thing I want to cover before we end the lecture today, and this is the idea of called normalization of deviance. Okay. And so it's a really fancy name, but it describes, I think, something that maybe a lot of us are familiar with. And so when you're using technology or something, it's not uncommon for the device or something to exhibit behavior that's not what it was designed for. Or in other words, the way I like to say it, it's not uncommon for your devices to do something weird. And so just like right now, like right before I let you guys go, my iPad was acting up and wasn't letting me connect back to the Zoom room. Okay? And so a lot of times, what we do is we kind of chalk these things up, when they occur, to like, oh, it was just being weird at this time. Okay? And so we kind of justify it just because we don't really want to deal with it. Okay? But when you do this a little bit too much, it starts to become something a little bit dangerous, right? Because if it's something, that just happened once, okay, maybe it was something just random. But if it's something that starts to occur more and more, you have to kind of guard against the temptation of being like, oh, it's just something random that's occurring, right? Because if it's something random that's occurring, more and more often, something might actually be wrong with your device, and you might want to get that looked at and to try to fix that. Because if you ignore these kinds of events under, say that you're working in like a nuclear plant, right? And say that, one of the pressure valves is doing something kind of weird every now and then, like it's making a noise that you're not really sure what it is. And so if you kind of ignore this, or you normalize this kind of deviant behavior, then you could be ignoring some of the warning signs that could lead to, really big catastrophic failure, that could have been prevented if you dealt with the problem, directly. Okay? And so you kind of want to be careful of this, because I think it happens, I think, more than I think a lot of us would like to admit. And so when these random kind of weird events occur, look into it every now and then, because it could be an indication that something is really wrong, right? Okay, so that's all the time we have for today. So so thank you everyone for tuning in. So I know it's kind of this is a tough week because it's right before Thanksgiving. So I appreciate you guys coming out and listening to the lecture, right? And so on Thursday we're going to start a new topic, which is organizational ethics. So basically, how do you act ethically within a company, and how do you protect yourself if you feel like your company is doing something wrong? Okay. Okay, so I'll see you guys on Thursday. So I have office hours after this if you want to discuss anything. So have a great day, everyone. And then until next time.
Professor,
Yep. Mm-hmm.
I actually have a question regarding homework 6.
Okay. Sure.
Okay, so for the introduction part, so do I just kind of like, let's say I'm doing the space shuttle, right?
Yep. Mm-hmm.
So do I just like give like a brief history of what happened with it, and like why is it important to study this case basically?
Yeah. I think
And
that'd be good.
okay, and how much ethics? So let's say like what you taught us in class, right? How much of it do we have to apply?
I mean, it depends on which case that you end up doing, right? So the case for the it was Challenger, right? So the case of the Challenger, it was actually the thing that we just talked about just now. It was a normalization of deviance. So that was kind of a big thing. And so the things that we talk about in class, like not everything is going to apply to every case study. So it's important to kind of pick out what was kind of the most important things that kind of led to in Challenger's case, it was a really big catastrophic failure. So what were the most important things that led up to that failure? Based on the things that we've been talking about so far. So you don't have to address every single thing, but just kind of the most important ones that kind of fit your case the most.
I see. So it's best if I look over notes and then just do the homework side by side, basically.
Yeah, I think that would be good. So one thing that would be good is also to I know we didn't go over explicitly in the class, but if you look up the code of ethics, so like the IEEE and the NSPE code of ethics, I think seeing how those apply to your situation, I think that would also be a good guideline to follow as well.
All right, so just some, so just take some from the two IEEE and then the other one, and then some from the notes, and I should get full credits, right? For like.
Well, I mean, it still has to be a coherent paper. Like it still has to flow really well. So
yeah, definitely.
Yeah, so I mean, it's I mean, write it like as if it's like one big coherent package. So I think just to kind of answer your question for the introductions, the introduction I think is it kind of gives almost like a foreshadowing of the entire report, right? And so it gives you kind of like you said, like kind of the big what's the big takeaway from this not only from the spatial itself, but why are you studying it in general? I think kind of explaining that in your introduction kind of briefly is good. And then for the rest of the report, you kind of go into a lot more detail about, why you think this is important and why it's, a good case study for engineering ethics.
Got it. All right. Thank you, Professor.
Yep. Mm-hmm.
All right, have a good day, Professor.
Thanks. You too. Ismail, did you have any other questions? Okay. So if not, I'm going to end the call. So thanks for coming, and I'll see you on Thursday.